We'll look now at integration by substitution. So the whole idea of this method of integration then is to take the most complicated part of the integral and substitute it for something else to try and make it a bit more straightforward to do. Quite often in exams, they'll give you what they want the substitution to be. So like in this first question, u equals 2x plus 5 to find the integral. Okay. One thing to remember, and this will become more clear when we start this example, you can't just interchange dx and du. They're not the same thing. Okay, that'll become a bit more clear in a wee second. So we have that u is 2x plus 5. So let's differentiate that because we need to know how are du and dx related to each other. So differentiate that, we get 2. So du equals, bringing the dx across, 2 dx, or you can say, well, that means that dx is going to be a half du. Okay, and the other thing we need to do in this is to rearrange this equation to find what x is. So u minus 5 would be 2x, so x would be a half u minus 5 over 2. Right, so now we're going to look at, there's all your sort of your pre-working out. We'll look at the actual integral. I'm going to change that to 2x plus 5 to the power of a half. So now we have to change everything here. So this is where your notation is really important. You can't just forget about the dx. So x we can write as a half u minus 5 over 2. This 2x plus 5 to the power of a half we can write as u to the power of a half. And then the dx at the end, well, dx is a half du. So everything in the top equation has to be substituted. So now if we tidy that up, so multiply a half by a half and the u by u to the power of a half, we'll get a quarter u to the power of 3 over 2. Minus, and then minus 5 over 2 times u to the power of a half is minus 5 over 4 u to the power of a half du. And then it's a straightforward enough integral to do. So when we integrate this, you're adding 1 to the index, so that becomes u to the power of 5 over 2, and then you're dividing a quarter by 5 over 2, and you get a tenth. Adding 1 to the new index, you get u to the power of 3 over 2, and then we're dividing 5 over 4 by 3 over 2, and we get 5 over 6, and then obviously we remember our plus c. And then remember that you were asked to integrate something with x's in it, so you have to put the x's back in at the end. So u was 2x plus 5. So we can put that back in. Now obviously there's ways here of taking out a factor and tidying that up a bit, but we're not going to worry about that. We're just going to worry about the actual integration. Our second one then, use u equals sine x plus 1 to find the integral of cos x sine x upon 1 plus sine x cubed dx. Okay, so we'll have u equals sine x plus 1. I can also write then u minus 1 equals sine x. In something like this, you won't have to find just x and so on. So in the first one, we had to change the subject, so it was x equals. You won't be asked to do that in trig. You don't want inverse signs and stuff like that in it. Okay, so we need to differentiate u to see how du and dx are related to each other. So differentiate sine, we get cos. Differentiate 1, we get 0. So we can say du equals cos x dx. Now look at the integral. So cos x sine x 1 plus sine x cubed dx. So remember, everything in this integral has to be replaced with things to do with u. So this part here, sine x, we saw over here, it's u minus 1. So we can write that as u minus 1. The 1 plus sine x all cubed, well, our u is sine x plus 1, which is the same as 1 plus sine x, so we can write that as u cubed. And notice what we've left now. We've got cos x dx, and you can see over here, well, cos x dx equals du. So we have replaced everything, and it's all in terms of u now. So we can multiply that out. So it's u to the power of 4 minus u cubed is what we're integrating, which is so much more straightforward than the integral we had. So add 1 to the index, divide by the new index, add 1 to the index, divide by the new index, and your plus c. And again, then just put your x back in. And that's our final answer. Okay, so example 3, then use integration by substitution to find the integral of 6x e to the x squared dx. Now, you could do this by using integration by inspection, but if the question says use integration by substitution, even if you get the correct answer, you will get no marks because if you don't use this method. Okay, so we'll have to use substitution. So this one hasn't given you the substitution. So they take the part of the integral that's given bother. So it's the x squared up at the top here. So we're going to let u equal x squared. So then du by dx is 2x. So we can write du as 2x dx. Okay, so let's look at our integral. Now we've got 6x e to the x squared dx. So I'm going to write that in a slightly different way, just looking at what we have on the left-hand side here. So we have 6x, but we've got du is 2x dx. So I'm going to write that as 3 e to the x squared times 2x dx. And hopefully you can see they're exactly the same. So this part here, we can change to 3 e to the power of u. And this part here, we can change to du. So that's what we're integrating. We're integrating 3 e to the u with respect to u. Integrate 3 e to u, you get 3 e to the u plus c, and then change the u back into x, which is 3 e to the x squared plus c. And our fourth one then, use substitution to evaluate the integral between 0 and 2 of x upon x plus 1 all cubed dx. So we're going to let u equal, the bit that's the most complicated is the one with the cube on it. So we'll let u equals x plus 1. So we can write u minus 1 equals x. Then differentiate u with respect to x and we'll get 1. So in this case here, du is dx, so that's nice and straightforward. Now this has got the added wee bit of the limits. So everything in your integral has to either all be in terms of x's or all in terms of u, and that includes the limits. So remember, your limits are your x values. So when x equals 0, our bottom limit, u will be 0 plus 1, so that's 1. And when x equals 2, our u would be 2 plus 1, which gives us 3. So they would be our limits whenever we change it into u's. So let's look at our integral. Remember, everything in the integral has to change into something to do with u. So x, first of all, then would be u minus 1. Our bracket here would be u cubed. And then our dx, we'll find out that du and dx are the same. So that's du. And we'll have to change our limits as well. So that would be 1 to 3. So now everything in that integral is in terms of u. So multiply out our bracket, so that's u to the 4 minus u cubed, and then integrate. So that's add 1 to the index, divide by the new index, add 1 to the index, divide by the new index. Now the good thing about these questions here with the limits, we've changed our limits into u, so we don't have to worry about putting it back into x and then putting in the x limits. We can just put the limits in as u. So 3 to the power of 5 is 243 over 5 minus, that gives us 81 over 4 minus a fifth minus a quarter. And when we work all that out, we get 28.4.